Hi everyone, my name is Mukul Sharma and this is my cloud computing and machine learning project. I'm going to walk you through my full pipeline, including data ingestion on a cloud style architecture, feature engineering, and supervised learning for match predictions, and clustering and association rule mining. So, as you can see in this cell, I'm using PySpark 3.5.0 to simulate a cloud-based workflow with the scalable distributed computing. The Spark session creation can be seen here, and I have also configured the executor memory and the core counts to match a typical cloud cluster setup. All the raw CSVs are stored in HDFS, that's Hadoop distributed file system, in the bronze layer, and then I'm storing the processed data as a Parquet in silver, in the silver layer. So the since we are dealing with real world football data, it's very messy, and Hadoop also has a tendency to add log files. Um, so sorry, not log files, these are like info log lines in the data set. So I had to create my own custom clean CSV function. It scans and filters out all the non CSV lines like info, log, timestamps, and stack traces. Then it finds the true header and rewrites the entire file into a clean, properly formatted CSV. This will have like a strict schema, so this ensures that the ingestion is completely robust for all the downstream processing. The different CSVs also had inconsistent column names. For example, home team written in all lowercase versus team underscore home. So I had to map these and I also had to parse multiple date formats to extract seasons and unify the EPL and the championship data sets into a single table. So as you can see, I have printed out all the columns that are there after doing all this. Now, once that was done, I did a quick sanity check by checking the distinct teams that are there per season, per league. And as you can see, the championship has always had around or had 24 teams, and the English Premier League after 1994 has always had 20 teams. So similarly, because each team plays another team in a round robin fashion, once at home and once away, by doing simple calculations we can confirm that this is accurate, where the number of matches are 552 for the championship and 380 for the English Premier League. Now I have taken data from 2000s to the current year, so I have filtered it out and stored all of it to the silver in a Parquet format, which is a columnar storage format, which is optimized for faster analytical queries and efficient storage. Then, just to confirm that everything is working, I printed the counts and also some rows to check if everything is fine. Now, the next thing that is very important is feature engineering. This is the core of the project. So, I engineered a range of predictive features, including the rolling average goals over the last three matches, then a 5 game form which is exposed as points earned, home and away season to date averages, goal difference deltas, and rest day calculations, league level indicators, and so on. So the count of the engineered rows is 20,680, and these are the some of the features that I have used. Just as confirmation, I googled some of the matches and from the season. So this is from 2000 to the 2000s to 2021 season, and I just wanted to confirm that all this data is accurate. Um, so after doing all of that, I split my data set into three parts: the training, validation, and testing. So all the training data was leading from 2000 leading up to 2021. The validation data set was 2022, and the testing was done on 2023 onwards. Now, after this was done, I basically used one hot encoding for the league. I imputed all the numeric features and I used a vector assembler to create the feature vector. I trained three models: random forest, gradient boosted trees, and logistic regression. For evaluation, I used cross validation with area under precision recall curve, as this is very reliable for imbalanced data like football match outcomes. So I picked a winner based on that, and as you can see with this output here, logistic regression achieved the best validation score, and therefore it became the chosen final model. Now, the um, test set performance was that on the held out test set, the model achieved an AU ROC of around 0.75, um, and an AU PRC of 0.70. Uh, so after choosing the best model, I decided to tune the threshold. So zero point 0.5 is the default threshold that is used, but when it comes to football data, it can be very unpredictable. So I decided to tune the thresholds, and I did this based on the best F1 score. And as you can see, I scanned different thresholds, and the best one was 0.36. At this probability cutoff, the precision is about 0.56, recall is about 0.86, and the F1 is 0.68. So the confusion matrix which I printed after that also helps break this down to show us the predictions versus the actual outcomes. A simple plot of the ROCAUC shows that this red dotted line, which is the baseline, it's random guessing, and the more this blue line bows towards 1.0, the better it is. So we are getting around 0.75, which is very good, because this basically means that we are not just randomly guessing, it's actually trying to use the features to actually make predictions. Now, once all that was done, I decided to create my own function to predict match outcomes. So based on a lot of those features, I could predict the results of matches based on reference dates. So here I've tried to see Arsenal versus Tottenham, where Arsenal is playing at home, and it predicted a win. And on the same date, if it was Tottenham versus Arsenal, based on their forms and all these different features that are being computed, um, it predicted that Tottenham would lose at home. And as an Arsenal fan, that makes me really happy. Um, the next thing I had to do was regression. So again, for this, I tried three different models: linear regression, gradient boosted tree regressor, and random forest regressor. Um, Based on this, random forest regressor had the best was chosen as the best model because it had the lowest root mean square error and the highest r square values. uh, Now, based on the outputs from this, we can see that the plot shows all the data points are clustered across along the diagonal, which is what it should be for regression tasks. Now, just as a sanity check, I googled some of the results from the matches, and here you can see that Arsenal versus Tottenham, it predicted 1.42 and the actual was 1, so that is great. For Chelsea versus Bournemouth, it predicted 0.82 and the actual was 0, which is also great. However, for Newcastle versus Wolves, it was an upset because it predicted 1.5 and the actual was 3. So this is showing that it is predicting and it's not just guessing, and also that you cannot have 100% chance of it predicting correctly. Now, the next thing to do was the unsupervised learning. So that is k-means clustering. This is the first unsupervised component. I constructed a set of 21 numerical features. Um, yeah, so that can be seen here. And I basically computed the silhouette scores uh, for K from 2 to 10. So as you can see here, um, so I got the at the best score, which was at K is equal to 2. And after training the final model, I examined the cluster sizes and centroids. So as you can see, cluster 0 and cluster 1 represent two distinct match archetypes. For example, one cluster tends to have higher goal differences and stronger form disparities. This helps identify structural patterns in the matches. The next task I had to do was association rule mining. This is the second unsupervised component, and I'm basically doing association rule mining using FP growth. I convert several engineered features such as league, form bins, and goal difference bins into categorical transaction lists. I then fit an FP growth model um, uh, with minimum support of 2% and minimum confidence of 40%. So, uh, this basically allows us to get human readable insights. It basically shows us that antecedent, if this happens, then consequent, then. So if and then, and it tells us the confidence with which this is the case. And yeah, so this gives us some high quality rules. So if the goal difference is high, if the goal difference is high and positive, then the result is a home win, and this is obviously with 100% confidence. So a large negative goal difference would predict away wins with high lift, and you could also have league specific tendencies. So as you can see, um, an away win, uh, if it is an away win and it's the English Premier League, then there is a chance that it's got a big negative goal difference in favor of the home team. And if the goal difference is small, then the chances of it being a draw are more. So to conclude, this entire project which I've created demonstrates a full cloud style machine learning pipeline with robust data ingestion, schema normalization, feature engineering, dynamic ELO updates, on supervised learning, model tuning, clustering, and association rule mining. It highlights the use of scalable Spark data frames and distributed machine learning techniques. Future improvements could include integrating player level data, injury models, or deploying the predictor as an API. We could also get live streaming data. That could be something to look forward to in the future. Um, Thank you so much for watching. I hope you enjoyed this.